All right, what if I gave you log base 2 of x equals 2? What would you do with that? Okay, I'm going to tell you, write that in exponential form. What would that look like?
2 to the second.
2 to the second equals x, right? 2 to the second equals x. Now, instead of an x, what do we got in that spot? We got this whole thing, but don't let that just throw you off. Do the same thing I just did. Okay, do that. So what's that going to look like? So you're going to rewrite that in exponential form. So that means 2 to the 2 squared equals, instead of x, it's going to equal log base 2 of x, which means that 2 squared is 4. So 4 equals log base 2 of x. So now I got rid of one of my logs. I'm going to get rid of my other log. Same thing. This is your base. That's your exponent. 2 to the 4th equals x. And then 2 to the 4th is 16. Okay, so the answer should be 16 for that one. So just go, you got to do the exponential form twice. 2 squared equals what's in the highlighter, and then you get rid of one of your logs, and then you just redo it again. All right, issues on the homework. What questions do you have or you weren't quite sure of?
29.
29? Okay. All right, let me do it. And then I'm going to do 17 and 19 just real quick because they tend to throw you off, and it's a real easy fix if you did get stuck. What is 17? Is that a cubed or a squared? A squared. 17 is a squared plus 2 equals 7. Well, before you can put it in log form, you got to get the a squared by itself. So just subtract 2, and you get a squared equals 5. And now you can say log base a, okay, of 5 equals 2. That's really all you got to do for that one, is just get that by itself. And then for 19, what is that? 2a cubed minus 3 equals 10. 2a cubed minus 3 equals 10. If I add 3, get a cubed by itself. And then I get a to the 3rd equals divide by 2, 13 over 2. Now they just leave it like that because if you looked at the answer, and I think what do they write? Log base a of 13 over 2 equals 3. So that's what that one should look like when we're done. So log base a of 13 over 2 equals 3. All right, 29. All right, what do we got for that one? We got 3 log base, man, my eyes are bad. Is that an 8?
Yeah.
3 log base 8 of 2 equals 1. Okay, and now, what did they say? They say 8 to the 1/3. So just divide by 3 here. Divide by 3. And so log base 8 of 2 equals 1/3. And so 8 to the 1/3 power equals 2. Okay, so that's all we got to do for that one. Hey, what's the 1/3 power? What's happening there? It's not the square root, it's the cube root. 1/3 power is the cube root. 1/4 power is the 4th root. So on and so forth. Now, 33 through 42 can be difficult. So let's see what you got here. Here's the even answers for those. So see what you got, and then we'll see what we need to explain. What's 57, 59? Okay, those are domains. 57, 59, and 69. Okay. 69 is like the last one we did. All right. Yeah, what you got, Eddie?
For number 40, I put -3.
You put -3 for 40?
Yeah.
Okay. So let's see. Log of 27, log base 27. is 3. All right, so it's 27 to what power equals 3? Now, since you put -3, what are you saying? You're saying that would be 27 to the -3rd. That would be 1 over 27 cubed. Okay, so when you use that negative value, you're going to get that 1 over. Okay, for that one. So when you're looking at it, so you got to say, all right, well, how do I do this one? 27 to a power equals a smaller number. So if it's going to be a smaller number, then you got to think root boxes like square root. And now in this case, it's going to be cube root. Okay, so we got to take the cube root of that. 3 to what power equals 27 is 3 to the 3rd. So we got to take the 1/3 power. Okay, for that. All right, others. Person. 42. All right, 3 halves. Log base 5. All right, log base 5 of the square root of 125. All right, how do we get 3 halves from that? 5 to what power? 5 to what power equals the square root of 125? So now how are we going to go about this? Now think about this. I'm going to go back to this. 27 can be written as 3 to what power? 27 can be written as 3 to the 3rd. So I can make that 3 to the 3rd to the x equals 3. So I'm going to show you a way to solve this other than just kind of understanding it. So now this means this is 3 to the 3x. 3 to the 3x equals 3. What is the power on that 3? It's not written. It's just a what? 1. So really, once you get to this point, if I got 3 to a power equals 3 to the power, what has to be true about those powers? They got to be the same. So we just say 3x equals 1, divide by 3, and that's kind of how I can get this 1/3. Now, most of you were probably like, oh, cube root. Most of you. Okay. Now, it's not quite as easy here. So we want to make this 5 to a power. Okay. Now, I'm going to do this in a couple of steps. 5 to the x equals the square root is the 1/2 power. Okay. 125 is 5 to what power? 5 to the 3rd. So I got 5 to what power equals 5 to the 3rd to the 1/2 power. Well, what's 3 times a half? We can just write it as 3 halves. So now this and this have to be the same. So that's how you get the 3. That's a way to get the 3 halves power. So it's real important that you know how to manipulate a square root into a power and how to take a power to a root. So like if you got a 1/3 power, that's the cube root. You got the 1/2 power, that's the square root. Okay? For that. All right. And that's a hard one. Didn't really cover one specifically like that. You kind of had to manipulate it. Any other questions though on any of those? No? Okay. All right. We're going to finish up those guided notes. We're still on target to have a quiz on Tuesday over 4.1 to 4.2. And all right, we're on the bottom of that back of the first page, I think. All right, we're going to talk about graph and logarithms and kind of getting some more of the basic properties here of the log. All right, f of x equals log base 2 of x. Now I'll just kind of go through that because this is graph and log is difficult. You need them. Ah, crap! They're in my other room. Shoot, let me run them. Huh? All right, you sure? Well, let me see how. It shouldn't be too bad. No, it's not too bad. All right, you'll be all right. All right, because this substituting in for logs is difficult. Because if you think about it, so we got f of x equals log base 2 of x. And we want to do x, y. Well, here's the problem. Can we take the log of a negative number? No. You can't do -2, -1, 0, 1, and 2. It's not easy. All right, here's what I would suggest you do. The inverse of log base 2 of x is 2 to the x. That is the inverse, and that's what we did yesterday. That we can do an XY chart pretty easily. If I plug in -2, I get 1/4. If I plug in -1, I get 1/2. 0, I get 1. 1, I get, hold on. So 1/4. If I plug in -1, I get 1/2. 2 to the 0 is 1. 2 to the first is 2, and 2 squared is 4. But what do we know about inverses? Their x and y's are flipped. So this is going to be a little bit easier the first time or two you do it. So if I do the inverse, I'm going to flip this so I get enough points to know what's going on. So it's 1/4 -2. It's 1/2 -1. It's 1, 0. It's 2, 1. And it's 4, 2. So under that first graph, plot those points. And like I said, I would do that because like you say, all right, what do I plug in for x? 2 to what power? And it's kind of backwards when you think logs. It really is. It's really difficult to kind of, figure out what points you're going to plug in. But if x is a fourth, that's because 2 to the -2 equals x. But typically you're not going to plug in a fourth. Okay? So you almost want to go backwards. You almost want to plug in the y values. So 2 to the -1 is 1/2. So 1/2 is my x. 2 to the 0 is 1. So my x is going to be 1. If you try to plug in 3 for x, 2 to what power equals 3, you're not going to be able to figure that out. All right, so we're going to plot those 1/2 negative, or 1/4 -2, 1/2 -1, 0, or 1, 0, 2, 1, 4, 2. Now that x-axis is a vertical asymptote, and it's going to go from -infinity up through those points, okay, to the right. Okay, to the right. So that's your log base 2 of x. Log base 3 of x would be similar. Log base 4 of x would be similar, except you got to have different points. So you do need to know, you're going to need to know these two graphs. You need to know 2 to the x, you need log base 2 of x. All right, same as before, we need to know how to do transformations on the function. So we need to be able to take that and just take your original function and then shift it whichever way, reflect it, however it's being reflected. We need to go through those. All right, well, if you got negative log base 2 of x plus 3, what does the plus 3 do? Just like normal, it's going to move it which direction? Left 3. It's going to move it left 3. What's the negative out in front going to do? Reflect it where? Over the y or over the x? Okay, that's always difficult. If the negative is on the outside, basically it changes the sign of the answer, which is the y value. So if your answer is normally 3, now it flips to -3. So this reflects over the x-axis. Now I'm going to start with my original function, which was -1 or 1/4 -2. It was 1/2 -1, 1, 0, 2, 1, 4, 2. Where should my vertical asymptote now be? If it moves left 3, then my vertical asymptote should be at -3. All right, I'm just gonna pause here for a second. And then if you're caught up, then think about where those points would be, or then I'll just wait until you get caught up. But it goes left 3, reflect over the x-axis. All right, so here, I'm gonna start on to the right here with 4, 2. I go 1, 2, 3, reflect over, so I end up here. And then I go left 3, 1, 2, 3, reflect over the x-axis. I go left 1, 2, 3. That's on the x-axis, so I can't reflect it. Go 1, 2, 3. It's going to reflect up to the other side. 2, 3. Reflect up to there. So it's going to go, instead of going to negative infinity, it's going to go towards positive infinity because we reflected it. Okay. So you still want to use the same concept we always have. Left 3, reflect over the x-axis. Take your original points, move those. It doesn't hurt to pick a point. What is that point? 1, -2. So what does that look like? So for f of x equals negative log base 2 to the x plus 3. So we're saying that x is 1. 1 plus 3 is 4. Okay, and then this is going to be -2. All right, how do I handle it? How do I handle a negative out in front? So think about this. So 2, in this case here, so think about this. 2 to the -2. I'm not sure I want to get into this. Here's what I can do to get rid of that negative. So I can divide by -1. So that gives me 2 equals log base 2 to the 4. And so 2 squared equals 4. So now we can justify that it works. So that does give us that correct answer. All right, now a bunch of these little rules come up that are going to be important on that next page. Okay. First 2 you're pretty comfortable with usually. Log base 3 of 3. 3 to what power equals 3? It's got to be 1. So that's got to be 1. 3 to the first power is 3. Log base 3 of 1 is going to equal 0. Now, what does log base 3 of 3 to the 4th equal? Okay. Now, all right, when you're not sure, you say, all right, it's got to equal some number, right? All right, so now if I swoop it, start with this, what does that become if I write it in exponential form? Becomes 3 to the x equals what? 3 to the 4th. So 3 to the x power equals whatever is we're taking the log of. Well, once you have it written like that, 3 to the x equals 4. What 3 to the 4th? What does x have to equal? 4. So it equals 4. How about 3 to the log base 3 of 4? 3 to the log base 3 of 4. All right, write that in. So 3 to the log base 3 of 4 has to equal a number x. Write that in exponential form. Or excuse me, write that in log form. Write that in log form. Okay. So log form, you would say log base 3 of x equals the exponent, which is this whole thing. So it has to equal log base 3 of 4. Well, look at this. You got log base 3 of x equals log base 3 of 4. That means x has to equal 4. Okay? So that equals 4. All right, here's what we want to show. And you can go through this to justify it, but it all has to do with like our bases. So I want you to think about this third one here. if you've got log base 5 of 5 to the 8th power, if these bases match up, the answer is just going to be the what? Power. Log base 5 of 5 to the 8 is 8. Log base 2 of 2 to the negative third is going to equal what? Not 2.
Oh, negative.
Not negative 2.
I said negative.
All right, negative 3. There we go. Negative 3. All right, so now same thing here. If I got 6 log base 6 of 12, that's going to equal 12. And you can do that to justify it, but we want to get to the point where we can just see it. 5 to the log base 5 of 3 is going to equal 3. Okay? So there's these 4 quick little rules that's going to be helpful to know. The first 2 you're really comfortable with. The second 2 you'll get more comfortable with. But if these bases match up, it's just that exponent, and we justified it over there on the right side. Same thing here. This base and this base are the same, but they got to be the same. All right, so now that just leads us to these basic properties that will always work. Okay, what we just kind of talked about. We just use it with base 3, but it's for any base. Okay, it is for any base. So yeah, this is where those basic properties of logs, it says 1, 2, 3, and 4. So log base 7 of 7 has to equal 1. Log base 4 of 4 has to equal 1. Okay, and those make sense. Log base A, any base of 1 equals 0. Okay, log base 8 of 1, 8 to the 0 power equals 1. All right, these two here, though, you're not as familiar with, so sometimes it takes a little bit longer, but those are important as well. If those bases match up, they gotta match up. So log base A of A to the X. So like we said, log base 5 of 5 to the M power would equal M, whatever that power is. If we got a base and we do log base A of X, it's automatically gonna be that X. So if I got 12 to the log base 12 of 7, that's going to equal 7. Okay, for that. What's it say? Okay, now, these properties work for the common and natural logs. Okay, so we're just hitting these properties a couple times here. So if you have common log, log of 10 equals 1, because it is base 10. Let me make sure I didn't make a mistake here. No, I had something on the guided notes. I think I must have fixed it. Log of 1, that's 10 to the 0 equals 1. Log of 10 to the x equals x. Ten to the log of x equals x. Okay, same thing here. Natural log of e to the x equals x, because that is the base. E to the ln of x equals x. Okay, natural log, e squared equals 2. E to the natural log of 4 equals 4, because that's basically dealing with the same base. Okay. All right, let's consider this. F of x, these are inverses, right? Where are we at here? Okay. F of x equals a to the x. The inverse is the log base a of x. Okay, that's always going to be that case. Well, going back to our inverses. Okay. F of f inverse of x. Okay, let's take a look at that. I take the inverse and I plug it into the x. So it gives me a. This x gets taken out. This gets put in the n. So it's a to the log base a of x. And what does that have to equal? a to the log base a of x. Okay, it has to equal x for two reasons. F of f inverse of x has to equal x, and we just did that property 2 slides ago that a to the log base a of x will be x. All right, now here's what I want you to do. Graph, hold on my calculator. Graph, so I want you to think what that graph should look like. Think what that graph should look like. You don't even need to know numbers, but then I'm going to tell you to graph 10 to the log of x. Okay, that would be similar to it. So I'm going to get your calculator, think what it looks like, and get your calculator out and graph 10 to the log of x, which would be equivalent to that. And let me see if I can. See if that'll work. Window. I'm gonna change my window. Zoom 6. All right, let's see what we got here. So we're just doing base 10. So we want to graph y equals 10 to the log of x, and we know it should equal x. So go ahead and graph it. And let's see what it looks like. So 10 to the log, L-O-G, whoops, parentheses, log of x, and graph. All right. Looks like that, right? Okay, we'll put an open, I'm actually going to put an open dot right here. Draw that in. Okay. All right, now take a look. What does f inverse of f of x look like? For this case, those two cases there, f inverse of f of x. So we're going to plug in f of x, which is a to the x. So it's going to be log base a of a to the x. Well, what should that equal? What should that equal? That's going to equal x. All right, now how can I graph this base 10? Base 10. So that's going to be y equals log of 10 to the x. So I can just do this. Log of 10 to the x. All right, graph that one. So replace your other one. So I'm going to do y equals clear log of 10 to the x power. All right, now I get that. Now my question to you is, both of these equal x. Why are those graphs different? Why are those graphs different? One starts at 0, 0 and goes up, and the other one, it goes all the way, has a negative infinity to infinity on the domain. Okay. All right, think about it. Why are those graphs different? What can't we take the log of? Negative numbers. So look at the first one. The first one right here is when we do the composition. It's 10 log of x, or it's a log base a of x. You are plugging your x into a log, which means you can only plug in positive numbers. So that is why when you graph that one, it only comes up starting at 0, going to the right. What are we substituting in on this bottom case here? We are substituting in for the exponent. You are allowed to plug in negatives to an exponent. I cannot plug negatives into the log. I can plug them in for the exponent. That's why those graphs look different. Okay, but they still have to equal x. It just depends where it's defined. All right, so a subtle difference there. All right, take a look at that one. All right, what you think about it? There's a couple of different ways to solve this. And I would say like one probably a little bit quicker, or might make sense a little bit better. All right, if you look at your properties, what does the natural log of e to the x have to equal? The natural log of e to the x has to equal x. All right, well, how does that apply to this? Okay, whatever the power is, has to be what that equals. Well, what's the power here? 3x plus 5, what does that have to equal? It's got to equal 14. So 3x plus 5 has to equal 14. 3x has to equal 9. X has to equal 3. That's why that property is really important. But you can still solve this without using that property. Anybody know how? You kind of do the swoop, convert it to a exponential function. Okay, now you got to consider we are taking the natural log of this. That means that is not your base. What is our base for the natural log? E. It's not written, so when I do this, this looks like this. The base is e. E to the 14th has to equal this whole thing and squared e to the 3x plus 5. So now you can make this 14 equals 3x plus 5, and you'll get x equals 3. This is kind of like the shortcut up here. If you recognize it, oh yeah, natural log e to the x has to equal x. I can take those and set them equal, but it's not the only way that you could do that. So you just got to be careful there. That is what we're taking the natural log of. That is not your base. So like if I tell you the natural log of y equals 14, that means e to the 14th equals y. But my y is that whole thing. Okay, understood? There's an unwritten base there. All right. Okay, that's it for that part. That's it for that part.